we should sync them up 2 weeks.
We should sync them. And we were going off of a master clock because it's easier, so that might start like 1 minute late. Or within 30 seconds of.
You can start streaming, Kate, whenever.
Yeah, I guess once it turns 1, I'll start streaming.
Yeah. This is just for Janine, so she knows how long the presentation's.
Right, I turned myself down so she couldn't hear me, but okay.
Hey folks, can you actually turn down Janine a teeny tiny bit?
Sure.
Sorry to mess it up. I forgot I only had one ear button.
Okay.
You,
Yes, I can talk.
talk so we can
Yes.
verify.
Emily, can you hear me in your one ear?
I can.
Okay, cool.
I have both
No.
earbuds in now, so you sound better.
I have no
Okay.
reference for how much I should have turned her down, so hopefully that was enough.
1
Thanks,
minute.
guys.
All right, I am going to start the stream because I have 1 p.m. on my machine, and we're going to wait until the in-room clock says 2. So quiet on Emily's end.
So 102, then we go to Emerald, right?
Correct.
Okay, so you can call that, Jake, when you go when you're coming, okay?
Oh, we have a problem. The stream key is incorrect.
Did you send?
The stream key, please double check your stream key. If it's correct, there may be a problem connecting to the server.
Uh-oh. We have a stream key problem.
We do have a
Does it-
stream key problem.
Does it matter that Francisca is connected, like she is streaming to Facebook and YouTube?
Oh, yeah, it actually does. That we can't do both. Is she doing it from Zoom?
Yes.
Then we'll just do it that way. That's totally fine.
Okay.
Interesting.
So what are you gonna do, send a virtual camera to Zoom then? Okay, we have 1 ear. So we are switching. We're switching to stopwatch mode. Turn cell phones off, everybody, if you have them.
All right.
Tell me when you're ready and I'll give you the countdown.
We're going to be live in
10,
soon,
9,
Emily.
8, 7, 6,
5, 4, 3, 2, 1.
Hi, everyone, and welcome to today's episode of MOS Live Science in Action called Spin Me Right Round, where we're going to look at the destructive properties of spinning something really fast. My name is Emily. I will be your moderator today, so that means that I will be the one to relay all of your comments, predictions, and questions to our educator today. Now, if you are watching us from YouTube or Facebook, please know that I can't actually see your comments right now, but please feel free to leave your predictions in the comments below the video. If you are watching us in Zoom, then you can use that Q&A box on your screen in order to talk to me and leave those predictions and questions. And also, if you'd like to see closed captions during the program, you can click on the CC button on your screen and then select Show Subtitles. So with that, I think that's everything that I needed to tell you. So we're going to hand it off to our educator and we'll get started.
Hi, everyone. My name is Janine. I'm so excited you are here. We're coming to you live today from the Museum of Science in Boston. We are inside of our Suit Cabot studio. This is a brand new space for us to bring museum learning experiences to you, no matter where you are. Now, for a long time, museum educators welcomed the public here to Suit Cabot and gave them the opportunity to explore real-world phenomenon, scientific tools, ask their own questions about science so they could flex their science thinking muscles. We're going to be doing that here today. We're going to be doing some exploring together. And like Emily said, we're going to be thinking about spinning motion. That's going to be the phenomenon we're exploring. And we're going to do it with a device that's right next to me. So right next to me is a large scientific demonstration we call the paper spinner. And I'm going to wait. There we go. So you can see it too. Yeah, it's big. And you see on the front of it, there's a piece of newspaper. Inside the paper spinner, there's a motor. That motor can spin at over 2,500 revolutions per minute. Now you might be thinking, what does that really mean? Well, I did a little math, And for a piece of paper this size, that translates to right around 165 miles an hour at the maximum. All right, that's really fast, 165 miles per hour. All right, so right away you might be thinking of some questions about this situation. And that's part of, thinking like a scientist, is you encounter something new and right away you have a question you want to explore. And that's going to be part of our journey today, is thinking about questions about the paper spinner and trying to answer them. We may answer some of them today. Some questions we may answer in a future episode. So if you have a question right away about what I've just described, what happens to a piece of newspaper when you spin it that fast, go ahead and share it in the Q&A box. Emily's going to start collecting the questions. And we'll see what you're curious about, because, yeah, I'm curious to hear what you're thinking. All right, now, while we're collecting those, Emily, are any questions coming in? We'll just wait a moment and see what's happening there.
Yeah, I do have one really interesting question that I just want to cover right off the bat. Vivian is asking if you, the scientist, are actually live on screen right now, or is this recorded, in the past?
Oh, I'm live right now. It is just a little bit after 1 o'clock, and I am coming to you from the museum live and in person. So, hi, Vivian. All right. Now, we're going to start with kind of a general question, right? What happens to a piece of newspaper when you spin it at over 150 miles per hour? All right. That's going to be sort of our experiment. Your job out there, friends, is to make some observations while this is going on. I want you to watch and listen. What are you seeing and hearing while the paper spinner is operating? What am I going to do? Well, I'm going to operate the paper spinner. I'm also going to be recording 2 pieces of information. I'm recording the time, how long do things take, and the loudness, the sound. How loud do things get? All right, and the way I'm going to record those pieces of information is with my smartphone. Smartphones are awesome. We're going to be recording the time in seconds and the loudness in decibels. So I'm going to set that up. And I am just about ready to go here. Okay. Goody. All right, I'm going to step back here and make sure that's ready. That's ready. I'm ready to go. Are you ready out there to start making observations? Remember, what are you seeing and what are you hearing? All right.
They are very ready and very excited, Janine.
Okay, good. I am too. All right. Here we go.
Whoa.
Okay. Right away, you can start sharing your observations. What did you see? What did you hear while all that was going on? And what I'm going to do is I'm going to record our 2 pieces of information over here. So I'm just going to step over here. Emily, you can share what people saw and what they heard.
Yes, we're finally getting some observations coming in. First thing that I'm
Awesome.
noticing are a lot of people saying boom and bam in the comments. So they definitely heard a sound like that.
Yeah, there was this loud sound.
They noticed it kind of exploding, and someone even uses the word expanding, as it was almost being stretched out while it was spinning so fast. We saw it rip. So there's definitely a... what's the word? A pattern to what's coming in.
Okay. All right. So I'm recording the 2 pieces of information. This took 20 seconds from when I started the motor to when the paper exploded. So that's the time. And it got to be a loudness, the maximum loudness was 63 decibels. So that's our 2 pieces of information. All right. Now, we watched that in real time, happening live right here in Suit Cabot Studio. And now we can check this out in a replay. We've got a replay where we can see this in slow motion, and you might be able to make some additional observations. So if we could get that replay, get going, there it is. All right, let's play that one more time so folks at home can have a really good chance to see that replay. It slows down. Okay, scientists, do you have any additional observations you'd like to share? If you do, put it in that Q&A and Emily will share them with all of us.
All right, just waiting a few seconds for folks to send in their observations. Let's see, I'm seeing one that noticed sort of the ripple effect moving through the paper as it was spinning. Someone says that there were folds in the paper that looked stable.
Yeah.
And we're still obviously noticing the ripping explosion at the end as well.
Okay, so once the paper gets moving, yeah, there's sort of this wave happening through the paper, and there's that loud buzzing sound, and eventually we get this explosion. All right, so right away, you're probably starting to think a little bit about, well, what happened? We know the piece of paper was moving. It's going from 0 to up over 150 miles an hour, going faster and faster and faster. We call that an acceleration. Also, we know the piece of paper has mass. So we have mass and we have an acceleration. You might know that force equals mass times acceleration. So you take the mass and the acceleration, multiply them together, and you get the force. The pushes and pulls acting on the paper. And right away, we could see that force was great enough to pull the paper apart. All right, so now we can change something about our experiment. We can change a variable. A variable is just some quantity you change, something you can measure. How heavy something is, how big something is, how cold something is. The variables we can change today around the paper spinner are the piece of paper. Because, well, the paper spinner itself, I can't change the motor. But we started with a piece of paper that was 22.5 inches in diameter. That measurement across the entire piece of paper through the center was 22.5 inches. I've got some other pieces of paper here. I've got a piece of newspaper that's slightly smaller. This piece of newspaper is 19.5 inches in diameter. I also have a piece of brown paper. This brown paper, obviously this is a different material than the newspaper, but its size is 22.5 inches in diameter. So the variables we can change are either material or the size. Now here's the thing with variables, friends. You get to change one variable at a time when you're thinking like a scientist. That way you can compare it to your original experiment. So Emily's going to launch a poll to figure out which variable you'd like to explore next.
All right, friends, so the poll is officially launched for those of you watching on Zoom, but for everyone on Facebook and YouTube, just so you know what this poll says, I'll read it to you. So the question is, which variable would you like Janine to change? And which circle of paper should she test next? And the options are the smaller newspaper circle, or a circle that's the same size as what she just used, but in that different brown paper. All right, so we're going to give people a few more seconds to cast their vote, and we're going to stop it here. There's a clear winner, and I'll share the results with everyone. It turns out that everyone wants to see the brown paper in that larger size.
Okay, well, let's get it going then. I'm going to set this up. So here's our brown paper at 22.5 inch diameter. I'm going to put this back on the front of the paper spinner and screw it in. And while I'm doing that, you all can make some predictions. Now, the predictions you can think about are, well, based on what we saw the first time, not, kind of what the paper spinner does. But you can also be thinking about experience you've had before with things that spin, things that move. And there are two things we can really make good predictions about, two things we can think about closely. Remember, we recorded time and loudness. So here's a question. Do you think the brown paper will take longer to get to the point where it fails and explodes, or shorter? Do you think the sound will be louder or less loud when it explodes? So you can share those predictions with Emily while I'm getting set up here. I think that looks good.
So I am seeing some really cool predictions coming in. Jonah is thinking that the brown paper will move more slowly, or maybe even that it'll take more force to get it to spin as fast as the newspaper. Vivian is thinking it'll take more time, but it will be louder. Let's see. I'm seeing a lot of people saying that it'll take longer to rip, and also a ton of people saying that it'll be louder.
Okay. Yeah, now this is great, right? We saw the paper spinner operate the first time. We collected a little bit of information about what it does. Now we can make some predictions based on that experience and our own everyday experience. And that's one of the ways scientists explore things whenever they're doing some experiments, right? They look at their results, they think about a question or a variable they can change and explore. Then they apply what they know and try to, make sense of it. All right, so I'm ready here. Remember, we're going to do this again, and your job is to continue to make observations. What are you seeing and hearing? I'm going to record time and loudness. I am ready. Let me get this. Okay, I'm ready. Emily's ready. I'm sure you at home are ready. So here we go.
Wow.
All right. Whew, okay. Go ahead and share those observations. I'm going to step over here and record time and loudness.
All right, friends, we're just going to wait a few more seconds for those observations to start coming in. Let's see. It looks like one person is noticing that it kind of looked like a wave as it was spinning. And let's see, Karen is saying, yay, it was a bigger boom. That's so awesome.
Yeah. From my perception, it definitely sounded louder, and our evidence supports that as well. The loudness was 79 decibels. Remember, the first time it was, 63 decibels, and it took longer, right? We got 27 seconds from the time I started the motor to when that paper exploded. The first time, it was only 20 seconds. All right. So we've collected some more information about this. And now let's go to that instant replay. And maybe we can see a little more detail or information we can gather. So friends, remember, we're doing the brown paper at 22.5. Go ahead and play that replay and see what we get. All right, friends, you could share your observations about the replay. I definitely noticed some things that I had never noticed before about the paper spinner in real time that I was able to see in the replay. I know a lot of people were talking about waves. You can start to see the waves. All right,
Yes.
Emily, go ahead.
So Vivian noticed that it almost looked like it wrinkled and then bam, exploded. I also want to add my own observation. I feel like the pieces were bigger this time when the brown paper broke. Someone is saying it looks like a disc since it's spinning so fast. Let's see. Someone else noticed something opposite of me, that it broke into more pieces than before.
Okay. Yeah, there's a lot going on here. One of the things that I want to tell you about the brown paper is that it's slightly heavier than the newspaper. I weighed both the papers. The brown paper is 3 grams more than the newspaper. So there's more mass there. The other thing, it takes, like, just ripping the brown paper as compared to ripping the newspaper. It took me more force to rip the brown paper. All right, so that might get you some thinking about what we saw here, right? That motor, when I started it, it took longer to where we got to the point that it failed, and there was a louder sound. So we got to a higher speed on the motor. We were going more revolutions per minute. We were approaching that maximum of 165 miles per hour. So we had more acceleration, more mass, and of course, what does that mean, friends? Yes, more force, a greater force. With that greater force, we got a louder sound. All right, so we've got time here to change another variable. All right, so we tried newspaper at 22.5 inches. We tried brown paper at 22.5 inches. And what do we have left? Well, we've got the newspaper at 19.5 inches. We also have brown paper at 19.5 inches. So those are the 2 variables we could change. We could change, we're going to go to a smaller size, but we can think about which material we'd like to do that smaller size in. So Emily, if you could launch the poll.
All right, the poll has officially been launched. So again, friends, we're choosing between brown paper in a smaller size or newspaper in a smaller size. So the question really is, which material do you want to see tested next? All right, so these results are a lot closer than the last one.
Okay.
I'll give it a few more seconds to see if a winner shows up. All right, we're going to end it right here. And again, these results were so close, but most people said the brown paper is what they want to see next.
Okay, the brown paper. All right, well, we'll get this on here. I'm having a little trouble with my microphone coming off my ear, but that's okay. Hopefully it'll stay on. I'm going to set this up. And while I'm setting it up, this is another great place to make predictions. We've got 2 trials we've done. We did the larger size in both materials. Now we're going to a smaller size in the brown paper. All right, I'm going to put this back on the front.
And friends, feel free to share any predictions that you're thinking of. What do you think will happen to the smaller brown paper compared to what happened to the bigger brown paper? Or even compared to the newspaper that we saw right in the beginning?
Yeah. And remember, we can think about loudness. Do you think it'll be louder, less loud, compared to one of the other 2 trials we did? Do you think it'll take longer, shorter? What do you think it will happen to the time? I'm getting this secured on the front.
All right, so some people are saying that it'll be even louder than the newspaper specifically. One person thinks that it'll take less time to break. Let's see. Yep, shorter time. Oh, one person thinks it'll take longer. So we've got a few different thoughts out there.
Yeah, there's a lot of thoughts going on. All right, I think I am ready to try this. I'm sure you want to see it in action, right? You see this thing go round and round. We got some people who think it's going to take longer before it fails. Some people think it'll be louder. Some people think less time. Now, compared to the bigger piece of brown paper, this is less mass, right? So we know that there'll be less mass this time. The question will be, what kind of acceleration can we get up to? How long does this really take? All right, so I'm going to step back here and get ready to start this. Okay, here we go. Oh, I forgot to turn it on. Now we're ready.
Awesome.
All
Good job,
right.
Janine.
Thank you. That was pretty impressive here in the studio. All right. So the time was 29 seconds. That's definitely the longest time we've seen this morning or this afternoon. And the loudness again was right around the same as the other brown paper. It was slightly more at 80 decibels. Let me record that over here. 29 seconds. 80 decibels. All right. All right, friends, do you want to share any observations? Go for it. There was definitely a lot going on there. You might have seen my expression that I was waiting for something to happen. I knew it was taking longer than it normally does. So the time was feeling a lot longer to me. And the evidence did play out for that.
So I'm mostly seeing a ton of people just still so excited that it's popping and breaking and exploding. Yeah, but it looks like everyone's pretty happy that what they predicted actually came true.
Yeah, so we can start thinking a little bit more about, the mass and the forces involved. And of course, since this took longer, we know we got up to bigger accelerations there, and of course, more force, which we got that really loud sound. All right, now I'm really curious what you'd like me to explore further with this paper spinner. Today we looked at, newspaper circles and brown paper circles in 2 different sizes. What other things could we explore with a paper spinner? Now remember, we can't change the paper spinner itself, but we can pretty much put any kind of paper on the front of it, and we can explore size. I don't know, just if you've got questions, you've got thoughts about what we could explore next with this, go ahead and put it in the Q&A. And hopefully in the future, we can come back with another session, spin me right round, and think more about the paper spinner together, do more investigation and flex those science thinking muscles. But if you've got a question right now that I haven't answered today, go ahead and share that too. We won't answer all the questions today, but I definitely want to hear what you're curious about.
So one person has already given us a really good idea for next time, which is using construction paper, which is a totally different material than what you use today. I feel like there was one cool question towards the beginning of the program. It's not exactly connected to what you were doing today, but just about spinning in general. And why is it that things in space seem to spin so fast? Like if something gets out of control spinning in space, why does it get out of control?
Okay. Yeah, that's a question we can explore in a future episode, thinking about here on planet Earth, we've got gravity and there are all kinds of forces acting on things as they spin in space. We don't have an atmosphere. Gravity, depending on where you're at, if you're close to a planet or far away from a planet, behaves in a different way too. All right. Now, one of the things I'm curious about, you can think about this, is, we did circles today. What if we change the shape? I don't know. Just think about that one. Maybe we'll come back with a different shape too. I'm super curious to see what would happen with a different shape of paper. Awesome. Well, I've had a lot of fun exploring with you today. I've hoped you've enjoyed exploring the paper spinner with me. We're super excited to be coming to you live today from the museum in our Suit Cabot studio. Yay. Thanks for joining me.
Thank you so much, Janine. That was wonderful. So folks, thank you all for joining us today. We had such a fun time coming to you from the Suit Cabot studio here in the museum, which is a change for us because we've been at home for so long. Now, if my friends could share that last PowerPoint with everyone, I'll just give you all a few websites that you can take a look at. One of them is where you can see other virtual offerings that we have at mos.org/MOS at home. You can also experiment with spinning on your own, and we'd be happy to see those experiments if you just use the hashtag MOS MOS at home. And then finally, if you enjoyed today's presentation and would like to support the museum, please think about visiting engage.mos.org/welcome. And with that, I hope you all enjoy the rest of your day, and we'll see you next time.